Alright, so today I've got a broken bolt in the driver pad in one of these sanders that I handle here. So there's supposed to be two studs coming out of here. There is part of a stud here which broke off, and it actually broke off in this driver pad here. So there's a couple of ways to get out a broken stud like this, and I'm gonna go ahead and go through all the different methods that I've used in the past. One of the methods is to take a screwdriver, and if this has an edge on it, you could just knock it around and just try to back the stud out. But I don't think that's going to work because that stud was actually stuck in there. Try to knock it out and then spin it out, and then twist it back out. But I really don't think this is going to work because there's not much of a lip on this stud that's in here. And the other thing too is that it seemed like the stud was stuck. It seemed like the stud was stuck when I was trying to get it before, because it should have just come right out. So I'm thinking whoever put this in here, they might have actually double threaded it, which means I'm going to have to end up retapping that hole anyway. The other method that you can do with this guy here, and I'll kind of show you there's the hole right there, stud's right in the middle. Okay, so the object is to catch it with the edge of this, if you can, if there's an edge in here somewhere where you can grab on, and then just kind of knock it around clockwise, or I'm sorry, counterclockwise to where it twists out. But that's just not working today. So the other method is to drill out the middle of the stud. And if this is a hardened stud, it's going to take a while to do this. Drill out the middle of the stud and then get it with an easy out. So, or just keep drilling until there's no more material left, and then just knock in the edges, and then it'll just collapse in on itself. So hopefully one of those two methods will get it. And either way, I might end up having to retap the hole. So I'll be back on camera once I have my solution in place. Okay, so now I'm going to drill through the center of the stud. That's what's left of it right there. And you want to make sure you're centered. You can center punch it or whatever you have to do to make sure that that's on center. Yeah, because the screw will want to walk on you, so I'm going to have to go ahead and center punch this thing just to make sure I get it down to center. So I'll be right back as soon as I center punch it. Okay, so now I'm going to center punch that hole just so I can get a drill started in there correctly. So basically, just take the old center punch. Whoops. Yeah, I don't know about this. I don't think it's hard enough. Oh yeah, okay, I did punch it. Okay, so there should be enough of a divot in there to where I can start a drill in there. I just need just barely enough to get a drill started and have it centered when it starts. So I'm going to go back to drilling it now, so I'll be back on camera when I do that. Okay, so now I've started a drill in there already, so I'm going to go ahead and drill it down, and probably all the way through. This stud's not that long. When you're using the easy out, you don't necessarily have to go all the way through it. But this bolt here it's not that long. So, and typically, if that's like a hardened bolt, it's usually case hardened, which means that the outside of the bolt is hardened and the rest of the bolt is, the center of the bolt is fairly soft, as soft as the original material was, because it's case hardening is usually a heat hardened process where they heat up the bolt to a certain temperature and then they harden it with either cyanide or some type of like an oil or something like that, that's used to case harden. Depends on the method that's used for case hardening, and it also depends on the grade as well. This isn't a grade 8 automotive bolt, so it's not the hardest bolt that you're going to find. But you can use the same method, drilling a hole through it. Now, there's probably other ways that I could have got this bolt out of here, especially since I would technically have access to it from the other side, because there's just a rubber pad under here, so I could go in from underneath as well. But I'm just going to use the method that I would use as if it were in an engine block and I couldn't get it out by any other way other than reversing it out. So obviously, the drill motion is moving in the direction of tightening a bolt. So whatever I do, if I decide to twist the threads out, I'll have to twist them out in reverse. I have a feeling that there was some type of cement or something used on this bolt, or maybe it was cross-threaded as I originally suspected, because it's just not backing out of here. The other thing too is that this is a bolt that's actually a hardened steel going into an aluminum piece, so there's a differential of metals there. I doubt that there was anything going on like electrolysis or anything like that, but sometimes that will cause bolts to get stuck, but not as stuck as this one is. This is a pretty simple affair here, I've got to drill down in there, so I'm going to continue drilling on this, and I'll show it once I'm starting to take it out. Yeah, and you can kind of see the hole that started in it already. So it's not exactly centered, but it's close enough for what I'm doing. Basically, I'm just going to destroy the original bolt that's there, and there's a good possibility, like I said, that I'll have to drill through the whole thing and then just tap it back out so I could put another 1/4-20 bolt in its place. 1/4-20 bolt is going to be one of the studs from one of these guys here, so I'll come back on camera once I'm to that point. Okay, so the hole is drilled all the way through it now, so I'm going to ream it out to the next size here, and I'm pretty convinced that bolt is fairly well cemented into there. It is drilled all the way through, by the way, so I'm just going to take the next size here, go through there. I still haven't gone out to the edge of where the threads are. It's a slightly off center, so I'm just being really careful about the way I approach this. It keeps catching the meat of the hardware there. Ay, ay, ay. About halfway through it here. So the likelihood that I'll have to collapse that bolt in that hole is pretty good, and then, or just drill it all the way out and retap the whole thing. If I can get it to that 1/4-20 size that I need it to be, that'll be good enough for what I'm doing. But since it's slightly off center, the hole here, I'm gonna have to make my best attempt at getting that hardware out of there. Yeah, this thing's being really stubborn. Okay, so we've gone all the way through it there now. I go another size up here. I'm going to go to 1/8 inch now, so let's about as big as I'm going to be able to do it without starting to get into the actual threads on the pad itself. And oh yeah, this is a driver pad. So when I'm talking about the pad, I'm talking about this. And this material here is part of that pad. So it's going to go ahead and drive it through one more time. There we go. Had to do it a little bit faster so it wouldn't catch. So now I probably have enough to where I could, possibly collapse that hardware in on itself. I'm not sure. I'm going to give that a shot, and then I'll come back on camera when I do. Okay, so before I go any further with that, I'm going to try to use the easy out to get it out with. So, you put it in the drill, and it's a reverse drill is what it is. It catches this, and hopefully it'll twist it out. This isn't the brand name Easy Out. It's actually Drill Out. So same thing, basic idea, and it's got different sizes in here for removing bolts. As you can see, what it is it's got the auger part, and then it's got the part where it actually twists into the drill. It has to be that size minimum to be able to get through there. So what this does is it cuts through the center of, where is it here? Okay, what this does is this cuts through the center of the bolt to a certain point, and then it catches on here. So that's the actual reverse screw part. So I'm going to go ahead and put it in here. I'm going to have to go left-handed now with the drilling motion. So I'm going to reverse the drill like as if I were removing a screw. And oh, by the way, this shank on this here, it is a hexagonal shank, so it's going to catch on these teeth better than an actual drill will. It's designed for torque, so now I'm going in reverse direction, as you can see, and I'm just going to try to get in there and get it to come out. The cutting head is starting to cut through that material there, and I'm kind of close to the edge here. I don't know how this is going to go. Yeah, we're still not quite at the edge of the bolt, so I'm going to go ahead. Probably should have drilled a little bit of a larger hole in there to start it with, so I just don't want to get to the edge of that bolt. But what I'm going to have to do is I'm going to have to drill out the next larger size, and there's still a little bit of meat left in there. Then I'll go in there with the Easy Out and try to get it out that way. And if I can't get it that way, then I'm going to have to destroy the bolt by knocking in the edges and then just getting to it that way. It'll crumble in on itself, and then I'll just remove all the extract, and then there should be some thread left in there. If there's not, I'll chase it with a tap. So I'll be back on camera here. Okay, so second attempt here. I just took a drill and chased it out. Oop, got to go the other direction here. Boy, it's really this is really a stubborn piece here. So it's likely that I'll have to oh yeah, I'm going the wrong way here. Okay. Yeah, it's just not able to grab it, so I'm going to have to collapse that, or just possibly just drill it all the way through, retap the original hole. It's off center now a little bit, so that's going to be a little bit of a difficulty. I'd prefer to get that out of there. The hole is not an exact fit. I mean, the stud comes up, it goes through a housing that, I can get it to go through the housing correctly, even though it's slightly off center here. So that's not a big deal. If that was the case to where it was an exact fit, I'd be screwed on this application here because I drilled it off center. But you know, it's not that critical. So let me just come back on camera once I'm to the point of getting the stud out. Okay, so now I've reamed it out as much as I dare, right to where it's at the edge of the threads, and now basically there's just the skin of the bolt left. So I'm just going to try to knock in the edges. Of that bolt, and if this fails, I'll end up having to just re-drill it and then just re-tap it for the 1/4 threads that it actually is, which is looking like that's probably going to be what I'm going to end up having to do. But I just want to give it my best shot and try to remove the bolt. And I don't know what the deal is. I don't know whether, like I said, I think it was probably cross-threaded in there. That's why it ended up like that, because it just doesn't make any sense how hard this is to get out of here. That's not a really high torque application. And there was, you know, well, yeah, maybe there was a little bit of heat transfer here since there was a sanding pad there, but not enough to cause a bolt like that to be welded into this hole. So what I'll end up having to do is I'm going to have to drill it through, and then I'm just going to re-tap it. So I'll be back on camera for that. I guess this attempt here has failed. So I'm going to try to do it a different way. I'm just going to re-tap that hole. And it will be slightly off center, but it's not going to be that big of a deal because it's not a precision application. Okay, so now I'm going to go ahead and drill out the hole. So I checked out the other holes. The closest drill size is a number 7, which is a .201 drill size. So I'm going to drill that out to a number 7 size so that I can tap it with this tap here. This is a 1/4 thread here, and it's going to go ahead and run it through. This is done in aluminum, so we'll go ahead and run it through. Probably should have done it on my drill press, but that's good enough right there. Okay, and it's going to go ahead and tap it out. Use a little bit of WD-40 in there. Just tap out that hole. And it should give me what I'm looking for. So I can twist those 1/4 threads in there. Run it all the way through. Just like that there. I think it's going through. Well, we'll see here. Just do it till it easy to tap, because I know it's gone through at that point. It doesn't appear that it's cutting anymore, and it has gone through, so let's run it a couple more threads through there. Okay, so we're good. Run that tap out of there, and then I'm just going to test the hole to make sure I can screw that 1/4 thread in there. In there, 1/4. Okay, there you go, and we have it. So that's basically how I had to attack this hole. Unfortunately, I wasn't able to get the thread out of there, the remaining thread out of there, but I was able to run it through, retap it, and it's going to be good for what I'm doing here. It is a rubber spring bushing, so we should have no problems with that hole. Thanks for watching. Okay, so today I'm replacing the spring rubbers on a Clarke sander, one of these OBS-18s. It's an orbital sander, you know, that vibrates in an orbital fashion. You put the abrasive on here, and it'll do wooden floors. So the driver pad here, which is this part here, has already been removed. Basically, to get that off, you know, there's a screw that goes onto an eccentric bushing that goes into here, and then it comes off. Now, normally there'll be an outer part of the shaft that will actually fit through here, but the counterbalance and the shaft actually came out when I took it off, so I'll just put it back the same way. To get this nut or this bolt out of here, it requires an impact driver. So you know, you're not just going to be able to get it out with a regular driver, because what'll happen is, or with a regular tool, because what'll happen is it'll want to turn the motor over when you're doing that. So that's why you have to use an impact driver, get it out at high speed. So here's the pad. There are spring bushings that go in here. I've already taken them out. They were completely ruined, so I'm going to bring you around here to show you the spring bushings. There it is. Okay, and see if I get any wider here. Okay, spring bushings go in. There's 4 corners that the spring bushings go in. These guys right here, they're completely ruined. They were wrecked. The back 2 were wrecked. The hardware was stripped off of them, so now I'm going to replace them with new spring bushings. This is the hardware that was stripped off of those spring bushings. They go into these corners here. I had a problem with this hole. I had to drill it out and retap it, so that's on another video if you want to look at that, in case that happens to you while you're doing this job. Basically, you know, these guys come here. They come in a set of 4. You just turn them into there. You know, you don't have to do them super tight because they got long threads on them, and then they have nice little locking nuts that go on the top with flanges built in, and then these little star screws, or these little stars here, which basically these are for the top part of this. So this is going to go underneath here, and it go underneath the driver. And what will happen is, when you've had this in place, it's going to prevent this from twisting while it's in there, so that it doesn't turn out of the material that it's put into. So I'm going to replace these guys here. Okay, just going to go ahead and put 4 of them in there. That's my freshly tapped hole. I'll remove this once I'm going to install it. Set of 4 of these guys, like I said. You get those things all over the internet. You know, you really don't want to pay more than 25 bucks for a set of those, you know, including shipping. Now, sometimes what they'll do is they'll ship you these with the bushing that goes into this part here, because this bearing, or with the bearing that goes in here, because this bearing, you know, that's the most common thing on this sander, are these guys and the bearings. Those are usually what go on them. Those motors, they're bulletproof. I mean, they'll be here till the next apocalypse. There's not really much that's going to damage one of those motors. The only possible thing that would go wrong electrically with one of those motors is the start capacitor, and you know, that's like a $400 part, but not typically, you know, something that goes wrong often. It just depends on how long you've been using the machine. You know, pull these guys off. I'm going to pop that pad back on there. So there's the machine right there. Now, one of the things about this is, the reason I put this screw back in here, or this bolt back in here, is because there's actually a pin in here that actually fell out when I was taking it out, but it's a registry pin. It actually goes along this part here, and it registers the oh, here it is. It registers this to lock this on to here, so, because this is an eccentric. So what that does is it's a counterbalancing It's a shaft that has a harmonic dampener on it to prevent the motor from getting the strain. So what it does is it puts the strain onto the driver pad, and that's the part that vibrates. So I put this into here to prevent the well, I would normally do that to prevent this little pin right here. I don't know if you can see that on camera. I would normally put that on there to prevent that little pin right there from pushing into there, because that is a pin that goes into my eccentric bushing, which you'll see here in a minute, and it registers this so that everything stays together, and it doesn't allow it to move around. So that's what that pin is for. And if you take this driver pad off and this part is left on the machine, okay, what'll happen is when you stand this machine up, it'll push this pin into that piece right there, and you'll never get it out. So I've done a few of these things, you know. I just take the preventative action. I put that hardware back in there, but it didn't come off the normal way. Like I said, the eccentric came off with the works there. So basically I've got to register this pin here with that shaft there. So I'm going to go ahead and do that right now and get it back on. There it goes, okay. And then I'm just going to go ahead and feed. Whoops, I forgot to take my hardware off. Got to take these off. Oh yes, so I've put the star bushings on here. Okay, one of them fell off when I was clowning around with it, but anyway, I put the star bushings on here, so I've got those on there so that they lock into place once they're in there. Then I've got to find that little bushing. Here it is. Let's go right on there. This guy goes right over that, and I got to register that hole. So let me just get it to the top position here. Register it. Like, this thing's a pain in the ass. Okay, it's all registered now. So now I'm just going to go ahead and feed these into the holes as they go up. Get those guys back there. I'm probably just going to stand it up and do it that way. Oh, there was an extra star left from the last set, so here, let me pull this star off of here. This star was stuck on here, and so was this one. Okay, new stars, start all over again. There we go, okay. Got to push these guys into here, push the back ones in, and then eventually it'll just drop on. So I can probably take a mallet and get that put back onto there. I'm going to find a mallet and I'll come right back on camera. Okay, so I located my rubber mallet. Now, if you don't have a rubber mallet, you can still use a heavy hammer. Just make sure to use like a block of wood if you're going to knock on that pad there. The reason is because this pad here is made out of aluminum. And, you know, you hit it with one of these guys, it's going to hurt it, so you can kind of do this number here. But I've got a mallet, so just going to go ahead and tap it in here. 4 corners. It is a friction fit setup, so it's going to take a little bit of tapping to get around there, but you get the idea. Okay, so now I'm going to put the pad on here. So I've got the star washers on the bushings. The holes are here again. Okay, registry pin right here, which is part of this counterbalance. So now I should be able to just put it on. These things are not easy to put on sometimes, so bear with me here while I do this. And you kind of want to look at the bottom part here to see where that top pin is. Okay, it just slid in. And you want to kind of simultaneously push these into their holes as you're pushing up on the pad. And the idea is to get these all pushed into their holes, and then you can start to go ahead and hit it with the mallet to fit the friction fit it onto the shaft here. So I'll come back on camera once I've done that. So bear with me. All right, so I had an issue here where this pad driver was not going on here. So what I did was I couldn't just push it on. Okay, I've got these spring bushings registered in their holes now. What I did was I took a long bolt that was the same size as this, okay, and I put it into the middle of the shaft. And what I'm going to do is I'm going to use this nut here. I've put the eccentric on here. It's registered onto the pin. I'm going to use the nut to push the pad driver onto the shaft because it's a friction fit, so it's kind of tough to get on there. So to get it done right, I have to do it this way. So just going to go ahead and put this guy here. The shaft will be in the same position the whole time. What I'm doing is I'm going to use the nut to tighten it with. And I'll just go in that direction. And it'll just tighten it, just like you're tightening on a harmonic dampener onto an engine. That's basically what I'm doing here. So just want to get it pushed on there. It seems to have pushed onto the shaft now, but let me just make sure. And yeah, the spring rubbers are all pushed up into place now, so it's going to be about its final resting place here. Okay, so all right, so we're good now. I'll loosen that guy, take it out of there. And then the rest I'll so this guy's on here. Now what I'm going to do is, since I've got this to this point now, I'll just go ahead and put the hardware in there because it will actually reach that hole. If you notice, it's kind of a short piece of hardware, so this is designed just to grab that when it's in position. So I'm just going to go ahead and put that on there. The pin is registered in this hole, and I'm going to go ahead and torque it on with my driver. So I'll be back when I do that. Oh, before I do that, I probably should show you the eccentric. Okay, so this is the nut that holds, or the bolt that holds everything together. The eccentric is exactly as it's described. It's got a hole off center for the screw shaft. It's got a register pin here, and the reason this hole is off centered is so that when it moves around, the pad vibrates. It rotates and vibrates. That's the way that goes. So that goes over the center part of that. Right here. Here's the registry pin. That fits this hole right here. Okay, and obviously that's where this bolt is going to go in. So just wanted to explain that, just in case you didn't get a chance to see that up close, because I kind of had it zoomed out. So I'll be back on. Okay, so I'm ready to drive that nut now. So it's actually a 3/4 head bolt. So let's go ahead and put it on there. Oops, I did it the wrong way. Anyway, the most important part here is to make sure that is onto the registry pin before you actually tighten it down. And since I just loosened it, I need to make sure that that's done so that I don't smush that pin onto that into that setup. Yeah, let me get that. Okay, it's on the very bottom. There it is. Okay, so it's on a registered pin. Put this in there, tighten it down. Make sure it's on the registered pin before I tighten it down. So yeah, okay, I can see the pin through there. So that means it's on a registered pin. And then I just go ahead and tighten it down. Okay, so it's tightened down. This guy's ready to rock and roll, except for I gotta put the hardware in the top here. So basically, I'm going to run one of those nuts onto each corner. Just like this. These ones appear to be a little bit bigger than stock. It's kind of nice. You got these guys, and then you got the new ones, which are wider. So they have a little bit of a wider footprint, which is great. Anytime you get a little bit more out of your hardware, you're going to be better off. So I'm going to put these on all four corners. I'm going to tighten it down. Then I'm going to run it through the test to make sure that it's not knocking anywhere, because the indication that this pad, these pad springs had to be replaced was that the pad was starting to come into contact with the top part of the assembly. So there's a rattling noise, and that's kind of the indicator that you might have broke one of those springs down there. You don't want to have those broke, because what will end up happening is that pad drive will, when all four of them breaks, the pad driver will actually spin around and it'll hit the wheels back there. It'll create all kinds of mess, and somebody's going to get hurt. So you really want to replace it once one of those is broken. There was actually two of them broken here in this one. So, you know, whoever had this before I did, shame on them. So that should wrap up the video for changing out the pad springs on the Clarke OBS-18 sander. Thanks for watching.